Hello, good morning, good afternoon, good evening, wherever you are. Um, my name is Nandu Vellal, and I'm one of the co founders of nAurava Technologies. And I do have the other two co founders, Dr. Ripi Singh and Dr. Shyam, as part of this webinar. Just a little bit of housekeeping before we get started. So please be mindful of any chat messages that you post in YouTube. As well as if you have any questions, please do post in the chat. If we can't get it as part of this conversation, we will get back to you later on. So the agenda for today is a little bit of introduction about who we are and what we are working on, the industry challenges with respect to industrial inspection, digitalization in industrial inspection, what are the needs of digitalization, and we'll talk a little bit about some of the use cases of what we have worked on. And finally, you'll walk away with some insights and the questions to ponder about how you can bring digitalization within your organization. With that, let's get started. So I'm one of the co-founders of nAurava Technologies. My background is in industrial inspection, mechanical engineering, robotics, 3D printing. Uh, I worked on the US Air Force SPAR Phase 1 to conduct a feasibility study along with Dr. Ripi Singh on how we can bring in immersive visualizations as part of NDE inspections. And I will let Ripi talk about now on himself. Ripi, you want to
Hello,
say?
everyone. It's a pleasure to be here, and thank you for joining us. This is a subject which is pretty important and very close to my heart. A little bit about my background. My first career was academics. I was a professor of aerospace engineering. Second career was in the corporate America. I left as R&D executive with one of the Fortune 500 companies. For the last 11 years, I've been practicing innovation coaching as well as digital transformation coaching. Thank you, Nandu, for having us here as your co founder and co pilot speakers for this webinar today. Over to you, Sham.
Shyam, we can't hear you.
Hi, good morning, good afternoon, good evening, depending on where you are in the globe currently as you join this webinar. So welcome to this webinar. And as mentioned, yes, it's a webinar on a topic of great importance, again, which is close to my heart too. A brief about myself. It's been a long career entirely in the domain of non-destructive evaluation and inspection, primarily focusing on developing new technologies for inspection of materials, be it during manufacturing or during in-service of a life assessment across the industry verticals of aerospace, oil and gas, power, energy, renewables, transportation, and so on. Has spent the first 16 years of my career doing ND technology development for the nuclear industry here in India. And then the next 20 years was with corporate General Electric, again doing the same thing across a broader domain of industries. And post-retirement, now working with a few startups to continue the journey on digitalization of ND primarily, which is going to be the future for all of us. Thank you. Over to you, Nandu.
Yeah, thanks, Shyam. So at first, we want to focus on what are the current challenges, and um, so we want to take a look at. So some of the challenges are, as the firms are mainly focused on solving their current problems, they don't have the long-term vision and visibility, and also the lack of leadership and strategization within the firm to ensure robust growth. As the technology is advancing, companies need to adapt rapidly to the changing conditions, both from the environmental conditions, the all the other socioeconomic conditions as well as the technological conditions. So that is one of the biggest challenges. There is also the changing workforce. So more and more experienced personnel are retiring, and there are not enough younger people entering the workforce. So there is some research that has been published by the Labor Department, so of which I'm sharing the link here at the bottom. Apart from that, specifically within industrial inspection area, so the challenge is like as newer products and materials are brought into the market, there are newer ways of building products, and how so the including the technology or the way we inspect is changing dramatically, and the amount of technology that's coming into play in terms of like how you inspect the products and even how you maintain. So there is a adoption that needs to happen within the industries to adhere to these changing technological advancements. And finally, there is a dearth of high quality training programs, and the also the other challenge is the workforce need to adapt to how they use these next generation technologies, whether it be AR, VR, XR, or mobile platforms, or even the newer instrumentation technologies that are coming out of the market to do their tasks and work, day-to-day work. So we see these as significant industry challenges that we are currently addressing. I will let Dr. Shan talk about the specific digitalization needs within the industrial inspection industry now. Sham, you're on mute.
Thank you, Nandu. So the the basis of most of the developments which are happening today around the world in the industrial inspection area is, of course, the development of introduction of newer technologies and advanced technologies. But then there is also a lot of things which are happening in the adjacencies, which is what we talk about in the next few minutes. So NDE, or non-destructive evaluation, is been there around for ages. Virtually every single industry which you can think of or talk of does use it in some form or the other. And then that is what essentially gives you the quality product which eventually you use in plants and assets and kind of structures, which again continue to operate for a long time or the design life without undergoing a huge amount of damage or failure. And both, if you talk about quality control in the manufacturing, that again involves a lot of ND. If you talk about installed components and structures and assets and all kinds of infrastructure, be it the power plant or the refinery or process plants, etc., you have both the challenges. One is that the newer components need to last for their design life, in spite of all the damage mechanisms which get incorporated, for example, fatigue, creep, or corrosion. And on the other hand, yes, there is another element of aging which also needs to be dealt with. And NDE and inspection really are the key elements which give you the necessary data to make a decision and a judgment on how long the asset should continue to work, or when does it need to be repaired or replaced. So structural integrity obviously forms an important element of NDE, and the fact that most industries do not want forced outages and downtime does give NDE a prominence, because it is the only mechanism by which you can determine, prevent failures, predict failures, and make sure that you have a more planned and predictive maintenance program in place. Of course, the fact that the complexity of materials and newer manufacturing process like additive manufacturing is coming into vogue, and they of course also have their own challenges to be addressed in the inspection world. Can we go to the next slide? So the role of advanced ND again need not be think as the materials become complex, as the designs become complex, as the increasing demand on detecting finer defects, improving the reliability of detecting defects like probability of detection, as we call in the NDE world. is all posing greater challenges on either advancing the NDE technique with newer methods or trying to have adjacencies like signal processing and image processing to enhance the information coming out of the data which we are collecting. So if you look at the world of ultrasound, we have now got phased array ultrasound, guided wave ultrasound, nonlinear ultrasound, and a variety of ultrasound technologies which have now made inspection much more efficient for different kinds of structures. If you go to the electromagnetic ND world, again you have the same thing. You had just conventional eddy current. Now we have got multi-frequency eddy current, remote field eddy current testing, array probe based eddy current testing, and so on. Similarly, with X-ray, from simple 2D normal film based X-ray, we have moved into the digital world with digital radiography, as well as 3D world with computed tomography, and so on. So a lot of different advances are happening, and that is coming not just out of its own, but because of the demand from the industry, and the fact that industry wants to be better and better in quality control, in product in process monitoring, in predictive maintenance, and so on. The fact that also we are dealing with larger structures and need the speed of inspection also has paid emphasis on non-contact sensors for wide area inspection. How do we do array probes, array sensor based inspection? And of course, in all these cases, the core thing which we are all moving about is in the digital world. Next one, please. And of course, the role of advanced ND continues. And if you look at the change which has happened over the last decade or two, is one is that most of your analog equipment has become digital in nature. So you pretty much have almost all technologies in utilizing a digital form of equipment in some form or the other. And then comes with the digital equipment, how do you do a better and faster data collection, which has brought in a lot of new generation scanners, robotics, crawlers, drones, and so on, which is helping us to do large area inspection in a much faster way and collect more data. And then, of course, once you have data, you need to do the data analytics to gather the relevant information, which helps you to even eventually make the decision, which is finally needed as the final step in any of these processes. The fact that both sensors have got miniaturized, the instrumentation also has got miniaturized and have become very portable for field inspection, which means these concepts need not be restricted only to the manufacturing plant. But today we can go out in the field, open pipelines, and do a lot of inspection right there on the field. Next one, please. So the whole concept of digitalization with industrial inspection and adopting and integrating is going to be the talk of the future. We are already embarked on that journey quite a bit, which you see, and there are several elements to it which you are already seeing. Any of you who are involved would see that there is so much of increased automation around you. The fact that the data mindset has already set in. Everybody is talking about collecting not only big but relevant data and quality data, which will help them to make better decisions. Of course, things like IoT, cloud computing, and storage. The fact that COVID brought in the revolution of remote inspection and remote monitoring, which is now becoming a norm in many industries. And all of these are pretty much helping us to get more predictive in our analytics and analysis, which is also helping preventing failures and giving early warnings. And of course, the newer concepts of digital twins, where we can have a complete digital entity of a physical asset, is probably one of the biggest developments in the last few years, which is going to revolutionize the way industry is going to do analysis and predictions on everything which they are kind of doing. And of course, the other pillars of what we term as NDE 4.0 is artificial intelligence, machine learning, augmented virtual reality, and things like crawlers, robotics, and drones. Next one. So one of the things which is again catching up and which has made significant inroads into many other domains, but NDE and inspection is kind of catching up on that, and we'll probably see more happening in the immediate future, in the near future, is all about augmented virtual reality, and of course extended reality, which is in some way a amalgamation and synergy of many things. And just taking one topic, that topic alone, you can see on the chart the number of things it can do. It can really help with the digital physical synergy. It can help in things like training. It can help in a lot of monitoring and traceability of inspection operations, which sometimes happen in remote areas, and maybe the level 3 sitting at a headquarters is was not able to see everything till now, but today all that can be enabled. Of course, effective and seamless remote inspection, and then of course the holistic visualization of the asset, the damage which it has undergone, and the inspection data. This holistic visualization is probably something which can ease the decision making process to a very, very large extent. And of course all of these needs a dedication of a lot of cognitive resources for inspection. And of course when you combine all of these, the synergy between the other enablers of NDE 4.0 and digitalization, like AI, ML, robotics, drones, which we talked about a little while ago, that synergy with this kind of extended reality, or the NDE metaverse, if you want to call that, is probably going to be the most impactful uh, direction for digital transformation, especially in the world of NDE and inspection. Next one. And so, in the basic summary of whatever we just talked about in the last couple of minutes is basically to see that enabling improved safety, improved availability, to maximize performance and improve reliability of assets, of improving quality control in manufacturing plants, is a amalgamation and kind of combination of everything which we talked about, bringing them together in the digitalized world can help you with a lot of industrial inspection improvements and make the industry and the world a better place to live. Next one. Okay, so with that, I would hand it over to Ripi to take it forward.
All right. So, Ripi, give me just a few seconds. It's just not yet refreshing here. So, give me 1 second. I'm just checking out on the YouTube. If you can please hold on to it. So,
Well, while we wait for you to set, I would, we all know the revolutions that people talk about, the industry 1, 2, 3, 4. Industry 1 was steam, industry 2 was electricity, 3 was computers, and the fourth one is this combination of computers and the physical systems in some kind of a closed loop manner. Fundamentally, a revolution or a transformation is when the way you work and the way you live and the way you execute things changes so much that you can't even recognize what it was before the revolution. The change has to be so radical that you cannot connect with it. Like today's kids, if you take and you show them the old phone where we grew up, where you had to pick the receiver and dial the thing, these kids can't even figure out that that's a telephone, right? So that's what revolution is about. You cannot even connect with it. You bring Wright brothers to the JFK airport and you show them this is what the aviation looks like now, and they will wonder, what the hell is that? So similarly, I want you to think about within the inspection world, how things would have changed. If you look at 2000 years ago, ever since humans have existed on the planet, the 5 human senses have been used to figure out whether something is right or wrong. You touch, Nandu, can you hold on to the animation, please?
sure. Yeah, go ahead. Go ahead. Yeah. It's refreshing, a delayed refresh on YouTube, so you can talk to the first two. Yeah.
So, we would hear something is about to break, whether we do a coin tap kind of a thing, or you touch it, or you feel it, or you smell it, and something is burning. So the human senses have been able to pick up stuff that was undesirable. Just when the steam engine came about, the need to check the mechanical systems and prevent the humans from disastrous consequences of an accident, we started getting into some kind of a structured inspection. And in the beginning, it was still visual, but it was structured. Structured in a sense, you do that inspection every few days and you make a note of what the situation is. And as the systems developed, the need increased to be able to amplify or highlight what's happening on the surface. So we developed techniques. It's not necessarily time wise, the revolutions in NDE. The NDE revolutions are more in space. The need and the technology developed where you could magnify cracks that were otherwise not visible with the naked eye. You do it with a dye penetrant, or you do it with a magnifying glass, or you do it with Mach particle. Same thing with audio. You use stethoscope to pick up audio signals and see whether something is breaking. So it was kind of, it changed the way we inspected things because we were now able to see things on the surface that we could not see before. Then the next revolution in inspection happened when you were able to see through the system, through the metal part, whether it's ultrasonic or eddy current or X ray. Then again, the inspection world changed. It revolutionized. Now you can find hidden flaws which were not possible before. The next revolution happened when we started the digital piece. This changed the game again because we were able to now store the information, share it very quickly across different places in the world, zoom in, do some kind of analysis on that. So the digital processing further revolutionized the inspection world. So now uh, we have been able to go deeper into the system and also able to share the understanding of what's happening inside the material. Let's look at what the fourth revolution can do. I want you to imagine, a bunch of kids playing in a playground and mom says that child is about to fall. How does the mom know? She knows because she has a correlation between children behavior and children getting hurt. So today, if we think of, we have so much data that tells us that certain utilization, certain way of handling things over a certain period of time, whether it is as per the mission or not, leads to certain damage accumulation and progression. And we can convert that data knowledge through artificial intelligence to be able to predict where the damage will show up in the future. So that revolution is what we call as NDE 4.0. It's about intelligent foresight. It's about having the extra sensory perception. Like just like inspectors also have ESP. Some of the experienced level threes will tell you there is something here. I can't see the signal, but there is something here. And 3 months later they find it. That same experiential capability, if we take into the data and AI ML algorithms along with it, we can revolutionize the inspection procedure where we can see things in time. That's how we define NDE 4.0. Thank you.
Thank you, Ripi. All right. So I'll just give a few seconds here so for the screen to refresh. So we'll talk about while the information is while I pull up the next slide. So we'll talk about one case study. We'll go a little bit detail in terms of how we are bringing in the digitalization as part of the inspection procedure, and we'll also show some videos about some of the other applications that we are currently working with a few of our potential customers. So one of the big challenges within the oil and gas industries is in terms of uh, specifically with respect to all the various assets in the plants, or they are subjected to harsh conditions in the first place, and also they're processing corrosive chemicals, and inspection of flange faces while the plant is in service is one of the key challenges. And as the technology has improved, what we are seeing currently in the industry, there are instruments that are able to not just capture the ultrasound information about the corrosion that occurs on the inside face of the flange, but they are also able to capture to a very high accurate level in terms of the wear that has happened due to the corrosion, in terms of the depth, the sizing, and it's able to provide much more better characteristics of this corrosion information that these instruments are able to provide. And what we worked with our partners was like to capture that information from the ultrasound reports and capture the data in 3D of how much the wear was, and we created the digital, I should say, like a mock-up or a digital app in terms of how we can visualize how corrosion is growing over a period of time. So at this point, I will show you, switch to the video that I can show here for a minute. So, okay, I'll just wait for the refresh to happen on the. Unfortunately, the refresh on the YouTube screen is somewhat laggy, so please bear with me. So what you see here is the uh, uh, the data that we captured from the corrosion inspection. We created a mock-up of like how the specific uh, the corrosion pattern is growing over a period of time. And what you see here is like that particular data that is showing in we have color coded it so that you can see like how it is growing over a period of time. And it's almost like green, yellow, red. So you're seeing over a period of time, and all of this that actual data was captured from the corrosion inspection, and the digital artifacts were created as part of this process. So this is one of the use cases. Now here in this scenario, what you're seeing is a robotic inspection of rails. We worked on a project for one of the leading railway organizations, where how we can build automation in terms of like how we can perform inspection of rails and in an automated fashion. And as part of this process, uh, what you see here is like you see that the as the inspection is happening, you the we are able to trace. Now all of this is built on pure physics, so you're able to track the specific location where the sensor is moving. You can see, you can also play around and change the sensor from a sled sensor to a wheelbase sensor. You can also see where the defect is located. We provide that visualization of the defect, and you can also there are additional cameras on the robot itself, and you can see those as well as part of the visualization. Okay. In this, so here is another example of a pick and place equipment that's being used in automation in manufacturing, right? So now here what we this is again, while this is an just a animation, we are currently in the process of building purely physics based visualization, so that you can change the conditions of how this equipment can operate dynamically and see how it's going to behave, right? So all the physics is programmed into the machine so that you can see, including there are IR sensors that can detect when a widget is coming in on a um, conveyor, and when the pick and place machine is the arm is picking it up and placing it on the rotary table, right? So you can see those visualizations. You can dynamically change. Where this type of a application helps is like when you're designing products and when you've built this automation equipment, not just automation but also inspection procedures as part of this, right? So we can mimic those. It's not just you're looking in 3D CAD model, but now we can bring it into an environment where you can play around with various conditions of how the machine would operate, including you can place digital humans and then see like how this is going to work, and how what kind of problems and challenges that you are going to run into, right? So this will help us model those kind of scenarios. Here is another application for oil and gas industry, what we have built. In this case, this is just a digital mock-up of a heat exchanger. What this provides is the capability that we can embed such visualizations as part of a workflow within. There are companies who are building workflow software for visualization of our capturing the inspection procedures. So we can embed this as a visualization widget within those applications. Now, what this gives is the ability for the field inspectors to, when they go to the field, to specifically look at where the potential defects are based on the prior inspection, and also when they perform the inspection today, they can tag and attach all kinds of information. Right now all of that is stored in some kind of you use a mobile app to capture that, but now you can also add visualization so that it can bring better clarity as part of the inspection procedures. Here is another application for which we built as a proof of concept for industrial inspection for US Air Force, where this is a VR application where we are providing, capturing the inspection that was performed, and the data is then used in a VR app where a user can literally move the digital probe and sense the defect, and not only just sense and see the signal on the screen, but also they can see the actual 3D information of the defect that has been captured. Here is another training tool, digital training tool that we built as part of the process, where you have a dummy part and even a dummy probe, and you perform the action of performing the inspection, and the data is simulated, and that data is then captured and rendered on the screen so that the users can see the actual C scan of the defect information. So this enables inspectors and training facilities to provide additional tools where inspectors can get trained and also get used to various different parts and processes that they can get trained on. All right. So those are some of the use cases that we have worked on. So we are also currently uh, We are also currently working with a partner, Flexi in India. So where they have built generative AI type of application for HR processing for talent acquisition, and we are kind of like at this point working to bring how we can do document summarization for industrial inspections, as well as what type of search capabilities we can provide in terms of historical records within industrial inspections, the generative AI application that can help the inspectors when they go onto the field for rapid processing and analysis of information. All right, I will now switch back to our presentation. All right. So, how do we engage, with companies? So, we have different capabilities for different needs of the companies. So we help companies with strategy planning in terms of analysis. We'll talk about this in the next couple of slides, in terms of where the companies are in terms of their digitalization and digital transformation. We provide technology solutions. uh, we provide business innovation, as well as coaching and employee training. So, Ripi, your uh,
Welcome back. This is a model that we built which helps companies define and design their transformation journey. And we struggled with it for a couple of years until Johannes and I finally figured out what the whole deal is about and why we get so confused about different people saying, "Oh, I'm already digitalized," and the others are saying, "No, you are not." So we thought we got to create some kind of a scale. It's not a maturity model, but it's a scale along which you can figure out where you are and what to do next. If you think about it, the ecosystem model that emerged during second revolution and became pretty clear by the time we got to third has a bunch of companies, and there are consumers who consume the value created by companies, and then government has these regulatory bodies that go on the whole thing. Within a company we have several processes. We have leadership that makes sure that company employees follow policies. Each of the process has an equipment. People use the equipment, they follow a certain procedure, and that's pretty standard thing. By now, for more than 150 years we've been doing this. When digital activities started penetrating the ecosystem, they start at the rock bottom, at the equipment that goes digital. When the equipment goes digital, it's called digitization. And that is essentially creating input and outputs in form of digital. We tend to think AI is fourth industrial revolution. Truly speaking, AI is still at an equipment level. It is getting to the process level now, but at the equipment level, it is still digitization. When people begin to automate at a process level and they get the digital skills and the procedures get automated, then the entire process becomes, and we call it digitalization. Okay, these are two different terms. Digitization is at the equipment level, digitalization is at the process level. When the leadership begins to understand and manage the business through digital tools, hey, don't look at an Excel file, but go into the ERP system and observe your dashboard over there and make your decisions and actions through that system. And your processes, the policies are enforced automatically through digital controls. Then the company can call itself that it's becoming digitally transformed. At that point, all processes are also digitally connected. So, in a digitally transformed business, your HR, finance, legal, production, design, quality control, those individual processes are digitalized and they are connected digitally with each other so that the entire value stream is digital. And if you can go to the top level where all of the companies in the supply chain gets digitally connected, the ecosystem goes through what we call as a digital transfiguration. So the digital penetration actually begins from the bottom at the equipment level, at the technology level, and goes in through the people and the process and the supply chain and the ecosystem. And if you can map that thing out, you can actually figure out where you stand today and where you can go tomorrow. And we have a nice little scale for that. Think about it. The whole progression or penetration of digital in here can be seen going from bottom up, from the equipment level to the ecosystem. The equipment level is called 3.0, and between the company and the ecosystem level is what is 4.0. And the question that you must ask is, what is our current state? How far can we see? How far do we need to go? And what is the infrastructure that is required to make it happen? If you can map your current state on this scale and put a dot somewhere that we are somewhere here between digitize and digitalize, and in the next 2 to 3 years we want to go between digitalize and transform, and maybe in 5 years we want to be fully transformed, you can actually build your strategy of how you will replace the equipment, the systems from analog to digital, and how will you connect them digitally to really work at productivity, quality, efficiency, cost, all of the traditional business metrics. And at that point, you can conceive new business models and new opportunities that were not even possible before. That's what your transformation journey should look like. Thank you.
Thank you very much, Ripi. So we'll leave you with this next steps. So you have our contact information, so you can reach out to us either via email or via phone or via LinkedIn. Please post us your questions and challenges, and let us know how we can help you. So thank you very much. Thanks, Ripi. Thanks, Sean. Thanks for uh, providing all the insights in terms of you know where industry is currently and how companies can assess within their own entities in terms of the health of their you know assets, as well as where they need to go in the future, right? So uh, I hope you all got some insights, and have a wonderful day. Thank you very much. Bye.